Hello, good afternoon. I'm Agustin Bilbao. I'm member of Aapresid, Necochea Regional Group. Today is Thursday, August 27, and this panel will talk about importance of coadjuvants to manage resistant weeds. The speaker will be Bryan Young. I hope you enjoy his presentation. To the right of the screen, you have a space to ask questions. You can make as many questions as you want on coadjuvants. And there is a tag in the Congress website that says speakers. You can find out information about speakers. Also in the commercial hall, we have the Aapresid space. If you click on the logo, you will be able to see different interviews. And in the social media, when you want to say something about the Congress, you enter the hashtag Congreso Aapresid. I will introduce Bryan Young. He's a botanics professor and plant pathology in the Purdue University, United States. Young laboratory is focusing on molecular characterization and the management of um, resistant biotypes resistant to Conyza canadiensis, bonarensis, and pigweed. He studies the minimization of herbicide use, minimizing drift in the use of herbicides. Trabajo en la Universidad de Purdue en Indiana, en Estados Unidos. Mi trabajo en particular es dedicarme a la enseñanza. Soy profesor en cursos de grado y posgrado. También realizo investigación en las malezas resistencias, técnicas de aplicación y además asesoro a la clientela que son productores, consultores y fabricantes. Hoy voy a compartir información sobre el uso de adyuvantes en herbicidas y cuál es su función en combatir malezas resistentes a herbicidas. Las malezas resistentes a herbicidas ha sido siempre un problema en distintas zonas del mundo y sigue siendo un problema importante en América del Norte y del Sur.
What an adjuvant is, to make sure that between continents there is no difference in how we define these individual products that we put either in the formulation or in the spray tank as a tank mix. So an agricultural adjuvant, by definition, is any chemical added to the spray solution other than the active pesticide or active herbicide in this case that enhances the efficacy or handling of the pesticide. And so adjuvants are needed as part of the herbicide formulation itself, but also they can be used by the applicator as a tank side additive that the applicator might use. And this is probably most common that we associate with agricultural adjuvants. But of course, some are used by the herbicide manufacturer as well in the formulation of their products. These agricultural adjuvants are also most commonly used with foliar applied herbicides. There are some used, obviously, in the formulations of soil residual herbicides, but most commonly we're trying to, get inside that plant from the foliar application. That's where these adjuvants can help the herbicide get to their target. And lastly, some tank mix adjuvants may only improve weed control under adverse conditions. So I know there's a lot of growers, applicators who want to see a benefit to everything that they invest in. Every single application, every single time they do it. But agricultural adjuvants aren't always like that. I view them as something that makes sure that you maintain consistency of activity even under these adverse spray conditions. And we'll talk more about that a little bit later. There's a lot of different ways to classify adjuvants. As you can see on this slide, spray modifiers, activator adjuvants, utility modifiers, and based on the chemistry itself within the adjuvant product. But for simplicity's sake, I just want to go with one way to classify them, and that's how they're listed on the pesticide label. So hopefully you find these different products, non-mixed surfactant, crop oil concentrate, modified seed oil, and so on the pesticides or herbicide products that you use, you find these on their label. And so that's how I'm going to be talking about these products today. The workhorse of the adjuvant market is, of course, surfactants. The primary role that they serve is break down surface tension. As you can see from the pictures on the left, we have a spray droplet without a surfactant applied for all three of these pictures. Then on the right, we have the same droplet, same spray solution with a surfactant involved to improve the adhesion and spreading out of that spray droplet on the surface. And you can see all the other functions that these surfactants also play in herbicide applications. But I do want to emphasize one thing, that surfactants aren't the only adjuvant you ever need. There are other roles for adjuvants that we need to optimize herbicide activity, because simply spreading on the surface isn't necessarily always good for herbicides to be absorbed. The further you spread that droplet out, the faster it dries, the least time you have for herbicide absorption to occur. So you can have such a thing as too much spreading on the leaf surface, and we need to keep that in mind, because these herbicides are moving into the leaf through diffusion, and that works best from a concentrated area into the leaf, not from a fairly diffuse concentration across the entire leaf into the plant. Now, I just want to go quickly through the history of herbicide resistance and where we are over the last 20 years or so in the US. So you can see back in 1998, I began my career in the university system, and I typically, smiled, and weed control was good because glyphosate worked. Glyphosate made weed control easy. It was fairly cost effective. It was actually extremely cost effective. So, my job was good, and I smiled, and we killed weeds. But now, you can see the progression. 2005, 2006, herbicide-resistant weeds started to play a role, like glyphosate-resistant Congreso species. Then we had the promise of other herbicide-resistant crops that are going to help save weed control in the future and help remedy some of this. And then about 10 years ago, that's really when we started to see huge impact of glyphosate-resistant weed species across the corn and soybean production areas, and even cotton in the entire U.S. and Mid-South. And then 2014, where herbicide resistance was the rule. So I stopped talking about glyphosate-sensitive weed species, and my focus was on primarily those weeds that we needed something other than glyphosate to manage weeds. And then here we are today, and you can see that I'm surrounded by weeds that are difficult to control, and I don't smile quite as bit at all. And so here's where we need to make sure that if we are applying herbicides, that we make each application as effective as possible. So this is what I call the herbicide-resistant weed era. This is where it's not very easy to manage these weeds, so it's challenging. Fragile, meaning you have to do things in a certain way and hope everything cooperates. The application is good, the spray conditions are good, the weeds aren't too large, it's not too hot out, it's not too dry out. And it can be expensive. If you fail and you need to spray again, the herbicides that are not called glyphosate are typically a lot more expensive than what glyphosate has been. And so failure is a major problem. And so these herbicide-resistant weeds have created major challenges. Weed management costs in the U.S. have probably quadrupled. So in other words, 4 times what they used to be when glyphosate was controlling our weed species. Again, to try and characterize our U.S. experience, because as we talk about herbicide adjuvants, I'm not going to be able to tell you that I've done research in South America and can tell you exactly what adjuvant X is going to do with herbicide Y. I can't do that, but I can share my experience with adjuvants being used in the U.S. for management of these herbicide-resistant weed species. And so that's the goal of this slide, is to share some of the herbicide-resistant weeds. You can see, according to a survey conducted by the Weed Science Society of America in 2019, in soybean production, the major weed species consisted of 2 amaranthus species and Congreso. They topped out the first 3. And then after that, some ambrosia or ragweed species, as we would call it, hypomea and chenopodium. One thing I want you to notice on here is we don't have any grass species or any monocot species listed in terms of being most problematic. We still have maintained good activity with glyphosate in most situations. However, resistance in grasses to glyphosate is on the increase, primarily, in my opinion, due to some common practices we're using over the last few years. But if we look at herbicide resistance that we have to the different groups, certainly glyphosate, which is a group 9 herbicide, as I'll refer to it as, group 14 herbicides, the PPO inhibiting herbicides, ALS herbicides, the auxin herbicides, dicamba 2,4-D, photosystem 2 inhibitors such as atrazine, very long chain fatty acid synthesis inhibitors, pyroxasulfone, metolachlor, acetochlor, and then also HPPD inhibiting herbicides such as mesotrione as being one of those. So we have a lot of resistance, and on the right, I'm showing some of the herbicides that we're relying on for management of these particular weed species. And you can see that some of these herbicides are the same as what we already have resistance to. And how does that work? Well, you need multiple herbicides to tackle it, so we're not relying just on auxin herbicides because we already have some auxin resistance. It's a combination of these herbicides, and of course, this resistance that we've documented is not on every acre. So there's a lot of acres where we don't have resistance to some of the effective herbicides that I'm listing over on the right-hand column. If we look at these, we're using PPO inhibiting herbicides, lactofen, fumesifin, flumioxazin. We are still using atrazine, dicamba 2,4-D, glufosinate, which I understand isn't a major player necessarily in South America, and it wasn't in the U.S. in soybean production either until about the last 4 years. We had other alternatives that we preferred, and typically they're based on glyphosate. So just to summarize that previous chart, the key points would be we have broadleaves or dicot weeds that are giving us the biggest challenge in terms of herbicide resistance. The most widespread glyphosate-resistant grass species, or monocot, is actually volunteer glyphosate-resistant maize or corn that comes up the year after we have corn production. We'll have some of the seed that is left after harvest germinate the following year in our soybean production. So actually, volunteer glyphosate-resistant maize is our #1 glyphosate-resistant grass species that we battle in soybean production. So I'm not going to be able to share today a lot of data on the glyphosate-resistant species that we do have for grasses in the United States, because I don't have data on those. One I do have data on would be maize. But I know a lot of the experiences that we've had with maize control, that's glyphosate resistant, are very similar to some of the other one, like echinocloa and panicum species that we are having challenges with glyphosate resistance in the U.S. Now let's compare this to South America. So based on the Ian Heap website, which I know a lot of us will reference, Amaranthus, Caniza, they are major issues, obviously. A lot of different herbicides, but glyphosate and auxin herbicides and ALS for sure. And then you have some of your grass species, which can be challenging. And that's where we don't have as much experience in the U.S., but we do have that resistance in maize that I'm going to be talking about. My understanding is that on the right-hand column, these are the herbicides that are still the major herbicides used for management of weed species in crop production, such as glyphosate, saflufenicil. Obviously, saflufenicil or heat that you would use is sold for improved management of caniza as well as some other species. Clethodim, haloxifop for some of the glyphosate-resistant grass species, and fumesifin and lactofen because of probably various species, but I know for one, the glyphosate-resistant Amaranthus species, especially Palmerae. So I'm going to go through 3 different weed species as examples where we're relying on adjuvants to improve weed management today. The first one is caniza, and our species is Caniza canadensis, the one that gives us most problems with glyphosate resistance. So in soybean production, our burn down herbicide options include 2 different routes. We can use glyphosate or we use paraquat. Within those, We have different combinations. So we apply glyphosate with 2,4-D, with dicamba, with saflufenicil to improve weed management. For paraquat, it's very similar. We can even have some combinations of paraquat and saflufenicil, but more commonly it seems like we're using 2,4-D and metribuzin or the combinations of those. So how do adjuvants get involved? When we're applying these weak acid herbicides, so 2,4-D, dicamba, glyphosate are weak acid herbicides, meaning that they have their ionic state will change depending on the pH of the spray carrier that you're using. So one thing that we want to do is make sure that we eliminate some of the hard water cations like iron, calcium, magnesium that might be present in our water supplies that we are using as spray carrier. And we use ammonium sulfate as a conditioner to remove or sequester really some of those hard water cations with the sulfate. And it also promotes better absorption of the ammoniated salts of glyphosate, 2,4-D, and dicamba to improve absorption into those weed species to improve control. The other thing that we'll sometimes do with these herbicides is we'll add additional surfactant, even if we're using a fully loaded surfactant product of glyphosate, such as Roundup products, especially under cooler conditions with challenging weed species. One in particular happens to be Chenopodium, that we see a benefit adding additional surfactant to help with herbicide efficacy related to glyphosate. Now, saflufenicil is interesting that's when we first started needing to use a different adjuvant system with glyphosate than just surfactant. It benefits greatly from the use of oil-based adjuvants. And we also observed through our research and in fields that the pH of your spray carrier is also important. And I'll go through that in a little bit further detail in a minute. For paraquat, again, combining that with 2,4-D for improved control of caniza, condition the hard water to make sure that 2,4-D isn't antagonized, additional surfactant or the use of surfactant is beneficial. I haven't found the need to go to a crop oil concentrate for some of these combinations. But when we move to metribuzin, that does benefit from the addition of an oil-based adjuvant for improving foliar activity. And that'd be true even when we apply that with 2,4-D. So if we want the burn down foliar activity of metribuzin, even with paraquat, an oil-based adjuvant is definitely warranted to optimize its activity and contribution to weed control. So I mentioned that pH of spray solution is involved with saflufenicil's activity. And as you can see here, we have a pH range from 4 all the way up to pH of 9. And in this, we do have saflufenicil in this solution. As we increase the pH from 4 to 9, you can see that the spray solution becomes more clear, meaning that the herbicide is going into solution better when it's clear, so at the higher pH levels. When we apply glyphosate put glyphosate in a spray tank, the pH typically is probably going to go down to about middle pH 5.5, 5.2. So it's in this range. And as you can see, saflufenicil, because it is ionic and changes its ionic state depending on pH, it's not quite as water soluble as it is as higher pHs. Now, if we want herbicides to go into the plant, it's great if we can get them to go into solution in that spray tank. But you can see when we're applying with glyphosate, that pH is lower and it's not going to be as water soluble. So if you don't have a water soluble herbicide, that's when we see a benefit to oil-based adjuvants. So if we look at this first graph of data that we generated several years ago, we have a non-extrafactant in dark blue, crop oil concentrate in gray, and in a lighter blue, we have methylated seed oil applied with saflufenicil and glyphosate on glyphosate-resistant caniza. Now, this is a half rate of saflufenicil, so we're trying to simulate complete control. This is research. We want to sort out the adjuvant benefit. That's why we don't have complete control here. But at pH 5, you can see that there is a significant, a 37% increase in control of caniza by using methylated seed oil compared to the non-extrafactant. And there was also a 23% increase just by going to a crop oil concentrate. So again, under pH 5, saflufenicil is not very water soluble. It's more oily. And that's where we're getting a big benefit from using an oil-based adjuvant. We compare that now to spray solution that has a pH of 7. We still see an increase in the activity of saflufenicil when applied with methylated seed oil and the crop oil concentrate. However, the difference isn't as great as when you had a lower pH, because as you move to the higher pH 7, saflufenicil is going to be more water soluble, and you have better activity even with just using surfactant, because saflufenicil is going to be, again, more water soluble. So less benefit at the higher pHs with saflufenicil, but there's still a benefit of using oil-based adjuvants even at those higher pHs. Now this looks at the extreme. We have two different scenarios in the field where we applied glyphosate and saflufenicil with crop oil concentrate at a pH 5, and then we did the same thing at pH 9. You can see better efficacy on Coniza at pH 9, but this is more of a demonstration than anything else, because we would not recommend you using a pH 9 for your spray solution for saflufenicil, because at higher pHs, saflufenicil will be susceptible to rapid degradation. It's not stable at higher pHs. So that's not recommended, but pH 7, it would be fairly stable, and so a slight increase would be good. One main thing I want to make sure is understood in the US, some of the effort with glyphosate to condition hard water has been to acidify that spray solution. And the spray solution might be down to low 4s. That is not going to optimize saflufenicil activity. So we do like spray pH being the 5s. Getting down below that with saflufenicil involved is obviously not going to optimize its activity and its contribution to managing Coniza. So to summarize management of glyphosate-resistant Coniza and adjuvant response, saflufenicil is optimized at low pH with oil-based adjuvants. You can even optimize it at higher pHs with oil-based adjuvants, but the greatest benefit came at those lower pHs where saflufenicil was not as water soluble as the higher spray pHs, okay? So what can we conclude from this? Oil-soluble herbicides and formulations typically require oil-based adjuvants. And I'm going to say this multiple times throughout the rest of the presentation. Oily herbicides, herbicides that are not very water soluble, benefit from having oil-based adjuvants. This is also a PPO inhibiting herbicide, saflufenicil. And we find that most PPO inhibiting herbicides aren't very water soluble, and so they benefit from these oil-based adjuvants. And then lastly, spray solutions that may be effective for glyphosate, such as just using surfactant, ammonium sulfate, may not necessarily optimize what else you put in that tank for a herbicide. So we have to keep in mind optimizing the herbicide that's going to do a lot of the work to kill that herbicide-resistant weed species in the field. The next weed species that I'd like to discuss would be glyphosate-resistant maize or volunteer corn. Again, I don't have data directly that talks about some of the glyphosate-resistant grass weed species in the U.S. because we don't have that many acres infested with them currently. They're on the increase, but not as bad as in South America. So we look at our options in soybean production for control of glyphosate-resistant grasses or monocots. We have two options. We use glyphosate in a Roundup Ready system and use ACCase inhibiting herbicides, what we would call the group 1 herbicides, or we use glufosinate in a Liberty Link system. But again, since glufosinate is not a systemic herbicide, it's not as effective as glyphosate for control of grass species because you don't get as much translocation. That's where the ACCase inhibiting herbicide is necessary to control some of the volunteer corn, as well as some of the other grasses that might have reached beyond 10 centimeters in height at the time of the post-application. So what do we use for adjuvants in these scenarios? Well, what we found out is, yes, we still need to condition hard water, and maybe, AMS is the most important aspect because we know that increases herbicide translocation, and that's critical for controlling grass species. In a foliar application, you need translocation in the phloem to get to the meristem. And this is true whether it's with glyphosate or glufosinate. Both those are water-soluble herbicides, but because of the ACCase herbicides being fairly oily herbicide, lipophilic herbicides, they don't like water, we find we need this oil-based adjuvant. such as a crop oil concentrate, in some cases methylated seed oil, to optimize their activity and actually kill some of the glyphosate-resistant grass species. So I have an example of some data that we've generated. Yes, we looked at 4 different rates of clethodim to see how much of that herbicide we needed and with what adjuvant system, which herbicide combinations to optimize activity. Typically, we're not applying rates down as low as 35 grams per hectare. But one thing I want to demonstrate is when you have clethodim applied with oil in the blue bars, clethodim plus 2,4-D and oil applied in the orange bars, you see a slight reduction at the low rates. Clethodim plus glyphosate, you can see there's some antagonism compared to clethodim applied alone. Now, I will tell you that for this combination, we're using the Roundup built-in adjuvant system, which is a surfactant. So part of that reduction in activity from 82 down to 46% control is because we're not using the right adjuvant system. But there's also antagonism just from glyphosate with ACCH inhibiting herbicides. And you can see when we combine clethodim with both 2,4-D and glyphosate, something that we might be doing currently in enlist soybean production, our level of activity went all the way down to 14% control of glyphosate-resistant maize. Now, increasing the rate of clethodim helped overcome some of this antagonism, but still for some of these, we didn't reach complete control nearly as much as when we did not have glyphosate involved in that spray combination. Even the addition of crop oil concentrate did not regain all the activity compared to clethodim by itself and crop oil. Now, one thing I should mention, in the US, we have different formulations of clethodim, and this is a formulation called Arrow, but it is just the active ingredient clethodim with no built-in adjuvant system. Conversely, there's another product called Select Max, which is clethodim and does have a built-in adjuvant system that is somewhat oily, if you will. And you can see when we make these combinations, we see less antagonism when combined with glyphosate, no matter what of the 3 rates we use. But we still did see some slight reduction in activity when you combine 2,4-D glyphosate and clethodim at the lower rates. So historically, for volunteer corn control, we were able to reduce the rate of clethodim for control of the species. But when we started combining glyphosate and 2,4-D in the tank, that's when these rates needed to start going up. In some cases, we recommend 30 to 50% increase in the rate of clethodim to overcome some of this antagonism and make sure that you're utilizing an oil-based adjuvant. In this case, for Select Max, it's built into the formulation of the herbicide itself. So you can see this in reference to our field trials, clethodim plus crop oil concentrate, the level of control we achieved by 28 days after treatment. Clethodim plus 2,4-D and crop oil concentrate, you can see a reduction in activity. And then the bottom picture, clethodim, 2,4-D, and glyphosate, where it almost looks like we didn't spray that at all, but indeed we did have clethodim 28 days prior to this picture being taken was applied. So surfactants and the built-in adjuvant system of glyphosate products is not sufficient to optimize all herbicides. It's great for glyphosate, and it's great for a lot of water-soluble herbicides that might be applied, but not for the oil-soluble herbicides that we're using today to manage some herbicide-resistant weed species, especially in this case, the ACCH inhibiting herbicides for control of grasses. Now, just to emphasize this one more time, glyphosate-resistant maize in the greenhouse. We have clethodim and glyphosate being applied at different rates of 2,4-D included in the mix. And on the right, this is when we applied crop oil concentrate with this formulation of clethodim that we used. So a stark difference in terms of the level of activity just because we used a better adjuvant for the herbicide being used for control of that glyphosate-resistant weed species. So to summarize these results, clethodim efficacy was reduced by the addition of glyphosate and auxin herbicides. In many cases, we could overcome a lot of that antagonism by increasing herbicide rate, but also the inclusion of crop oil concentrate was important, but you could also use a modified soybean oil or seed oil to also help rectify some of these problems. And in conclusion, herbicide combination to control herbicide-resistant species can be antagonistic in this case, especially ACCH herbicides where translocation is limited We have a lot of absorption. You can have up to 90% absorption of these ACCase inhibiting herbicides within 1 hour after application into grass species. But they have very limited translocation that might occur. In some cases, less than 40%. In other cases, maybe up down to about 5% translocation. So if you influence translocation at all by other tank mix partners, you can dramatically antagonize efficacy. So adjustments in herbicide rates and adjuvant systems can regain some of this activity, but maybe not for all herbicide combinations. And like I mentioned before, oil-soluble herbicide, it's ideal to match with an oil-based adjuvant system. And then now we move into the last weed species, which is glyphosate-resistant amaranthus. This happens to be water hemp, as we call it in the U.S., an individual plant as well as a field that had, a severe outbreak that wasn't managed in a particular year. So what are we using for management of glyphosate-resistant amaranthus? I'm going to cover both corn and soybean because there's some herbicide modes of action and chemistry that's of interest here. In maize or corn, we're using glyphosate tank mix with atrazine, HPPD inhibiting herbicides like mesotrione, and auxin herbicides such as 2,4-D and dicamba. In soybean, we have combinations of glyphosate or glufosinate, depending if we're in a Roundup Ready or Liberty Link system. And we're tank mixing in PPO inhibiting herbicides such as famecifin and lactofen, like you are in South America, as well as auxin herbicides 2,4-D and dicamba, depending on what soybean genetics have been planted in that field. For adjuvant systems, atrazine, HPPD inhibiting herbicides benefit from an oil-based adjuvant system, and that'd be preferred commercially for these combinations right now. Early on in the adoption of these herbicides in combination with glyphosate to improve control in amaranthus, they found that surfactant, regular non-active surfactant, was not sufficient to optimize control. So oil-based adjuvant was warranted to improve overall weed control. Auxin herbicides, it's not the case. They're water-soluble herbicides. You need to condition hard water to remove those cations that can be problematic, using ammonium sulfate, and we might use additional surfactant depending on the specific herbicide combination with glyphosate. In soybean, well, we're using some oily herbicides and PPO inhibitors, and so there it's justified to use oil-based adjuvants. And when the auxins are involved, 2,4-D and glyphosate, conditioning hard water, AMS, maybe surfactant, because glyphosate, glufosinate, and the auxin herbicides, they're all water soluble. So surfactant typically is sufficient to optimize that and improve management. I will mention right now that after we started to have glyphosate-resistant amaranthus in soybean production, there was a product that Syngenta marketed called FlexStar GT in the U.S., which was a combination of glyphosate and famecifin. During the first year of adoption by growers, they just use a non-surfactant ammonium sulfate for control because there was some concern that famecifin would cause some soybean injury in terms of bronzing or necrosis on the soybean leaves, and that would be less than appealing for a lot of soybean farmers. But we also noted that weed control was not adequate. So in the second year of commercialization of this premix of glyphosate and famecifin, the main recommendation was methylated seed oil and ammonium sulfate to optimize that to make sure famecifin would have good activity to kill the glyphosate-resistant amaranthus. So that was a broad-scale experiment in year one, hoping that surfactant was sufficient, but they found out that no, famecifin needs an oil-based adjuvant, and we're relying on that too much not to apply that with that herbicide combination. Moving back to corn, the HPPD inhibiting herbicides, you can see here with the different adjuvant systems, non-surfactant compared to the other three all have some oil inclusion in the adjuvant, crop oil concentrate, methylated seed oil, and this is kind of a new one over the last 10 years, high surfactant oil concentrate, which is kind of like a 60-40 combination of oil and surfactant. So they do have some oil, and that is where we're seeing some improvements in grass activity, Ceteria, and even on amaranthus, we're seeing some improvements in activity of timbertrione, in this case on amaranthus. I will note again that this is a reduced rate of timbertrione just to sort out adjuvant differences in terms of efficacy. But again, HPPD inhibiting herbicides are not very water soluble, they're more oily, and they benefit from the inclusion of an oil-based adjuvant. In soybean production, I kind of mentioned this already with the FlexStar GT concept with fameciphin and glyphosate. We were making our own tank mix combinations when we did this research back in 2008, before that commercial product was sold. So glyphosate applied by itself gave us zero control of Amaranthus tuberculatus, which we call water hemp. When we added lactofen or fameciphin, we saw a huge increase in control. And the addition of methylated seed oil improved control marginally. It wasn't a great increase, 8% and 7% increase compared to the built-in adjuvant system of Roundup Power Max. So the fully loaded surfactant product that we hear here in the US. So we saw marginal increases, but again, commercially, it was significant enough that commercially the recommendation was to use methylated seed oil to reduce the chance of failure with these PPO herbicides being applied for Amaranthus control. A herbicide that I know you don't use very much, but we are using it here in the US in Liberty Link systems, we have glufosinate. And I'm trying to emphasize here the use of ammonium sulfate and the importance of droplet size. On the left, we have what is a good application with the appropriate droplet size and ammonium sulfate being used. On the right, we have glufosinate on Amaranthus palmare, where we use a poor application. We didn't have the right size droplets. We used larger droplets, and we didn't use real AMS. So what's interesting on the right is glufosinate applied with a spray system that worked effectively for glyphosate or Roundup. That same application system, same adjuvant system, was not good for glufosinate. You have to change your sprayer setup and your adjuvant system for glufosinate to work effectively. So to summarize Amaranthus control, oil-based adjuvants are well justified for inclusion with glyphosate or some of the other herbicides where we're using PPO inhibitors as well as HPD inhibiting herbicides. Advantage over surfactant, though, is not always evident. And that's where it's important to note that I mentioned at the beginning that adjuvants don't always cause a great increase in activity compared to the same herbicide not applied with them. But what we're trying to do is manage our failures. And the use of adjuvants should improve consistency of control so we don't have those failures. And under challenging conditions is when that might happen. That's where adjuvants really have a significant role to make sure we don't have these failures. So herbicide optimization was through improved application methods as well as adjuvants. So they're tied side by side. You can't have the better adjuvant system, but then fault with how you apply that herbicide solution. You need to have both in mind when applying these herbicide combinations for control of glyphosate-resistant species. So to conclude, adjuvant response is not as extensive as other weed species. So with Amaranthus. So we don't see as great of an adjuvant response where you see 10% control, you use a magic adjuvant, you get 100% control. We don't see that Amaranthus like we can for other species such as some grasses. Another thing, poor practices can lead to progressive evolution of resistance. We saw that using poor adjuvant systems, poor application practices led to more problems with glyphosate, to where we had significant issues with glyphosate resistance. So conclusions overall for this presentation. Use of application methods, adjuvant systems that optimize activity of the herbicide being used for control of the herbicide-resistant weed is ideal. So that might not be Roundup. It might not be glyphosate. You have to optimize the tank mix partner that is doing the work to kill the resistant weed species. Built-in adjuvant systems might not be functional for all those tank mixes. However, we have to keep in mind that if you build an adjuvant system for that tank mix that doesn't optimize glyphosate, we might be sacrificing some activity on glyphosate on other weed species that might not be resistant yet, but you might be encouraging resistance because you don't have that optimized for glyphosate. In our case, it'd be not using ammonium sulfate in applications with dicamba and glyphosate for concerns of volatility. Because we're not using AMS, I feel that we're not getting as good a grass control with glyphosate, and now we're having more problems with grass weed management in those systems. Match the herbicide and adjuvants with similar water solubility, oily adjuvants, oily herbicides. The only way to herbicide combination be effective for managing herbicide-resistant weeds if each herbicide can control the weed independently. Now, we're not doing a lot of that. Typically, we're using one effective herbicide with glyphosate on a glyphosate-resistant weed species. So we're relying strictly on one herbicide. Ideally, we have two effective herbicides working for all applications. So there's things associated with foliar herbicide applications that can be managed in terms of the herbicides, rate of the herbicide, the adjuvants being used, the sprayer setup, the water quality being used, and there's things that we can't manage. Problems with the weed species. Some weeds are just tough to control. There's inherent resistance frequencies, the environment, drought, heat, things that we can't solve. So we have to focus over here on the left where we can manage the rate and the adjuvant. So make sure we have the rate of the herbicide that's appropriate and the adjuvant system to make sure that herbicide is going to function properly. One of our bigger challenges over the last 20 years, we've been very focused on post-emergence foliar applied herbicides. Our biggest challenge is we wait until the weeds are too tall. If we spray weeds when they're smaller, a lot of different adjuvant systems can work. When we wait and apply when the weeds are much larger, we need to make sure we have the right adjuvant system to control some of these weed species, because herbicides not called glyphosate can't kill tall weeds. So in the era of herbicide-resistant weed management, failure is not an option because it's expensive in terms of crop yield loss, it's expensive in terms of weed seed production that might be resistant, and it can be expensive in terms of the herbicide cost expenditures. So I greatly appreciate your time today. I thank you for the time that you've invested, and I appreciate the possibility of hearing from the group if you might have any questions. Greetings.
Thank you very much, Bryan. Your presentation has been very clear. We have quite a few questions. I hope they ask more questions because we have 20 minutes to ask questions. And so we know he can teach us what he knows. What do you think about premix adjuvants, NIS plus an acid?
Using non-ice surfactant with a weak acid herbicide, so one that is fairly water soluble, typically is a good mixture. Again, water soluble herbicides such as a weak acid herbicide, the auxins, 2,4-D, dicamba, glyphosate, even glufosinate, all water soluble herbicides. They would mix very well with the non-ice surfactant and probably be optimized with that same surfactant system as well.
Muchas gracias. Tenemos...
Thank you very much. Could we consider pre-emulsified mixture before filling the tank with PPO and methylated soybean oil?
That's a good question. So once you add some of these pesticides in the tank and try to emulsify, before you add something like methylated seed oil, I think in the end, with the agitation that you might have, it's hard for me to believe that you're going to have anything different in terms of the chemistry in that tank by trying to do that pre-emulsifying step. So I think you're still going to end up with your herbicide, with methylated seed oil, and they're going to interact still. I don't think that pre-emulsifying step is going to prevent any of that interaction with methylated seed oil if you're trying to favor, here's the oil-soluble herbicide mixed with methylated seed oil, but there's another fraction being applied with, more water-soluble herbicide applied with more surfactant base. So that's a tricky one. We do have products in the U.S. right now that in trying to combine water and oil-soluble herbicides in the same tank, We would call those high load surfactants, in which they have a higher loading of surfactant in with the oil-based adjuvant. So instead of 80% oil, 20% surfactant for something like a crop oil concentrate, we would have maybe like a 60% oil, 40% surfactant. And it's not your common surfactants. They're special surfactants that are indeed micro emulsions. So different than what you get in a normal herbicide mixture. So there has been some use of that, some utility. We have found good results with those type of blended adjuvant systems that are available on the market now in the U.S. for water and oil-soluble herbicide combinations. But I'm not familiar with too many, or any really, to tell you the truth, where they're pre-mixtures in with the herbicide active ingredient already to blend in with oil or water-soluble herbicides.
Perfecto, muchas
Thank you very much. The next question has to do what you showed, that there is an antagonism between glyphosate and clethodim. Does this antagonism remains with the different formulations of glyphosate, or can we achieve any difference?
So in our research, we have seen the antagonism between glyphosate and clethodim for formulations of glyphosate that didn't contain any additional surfactant system at all. So essentially glyphosate and water in that formulation. And then we've seen it with different salts of glyphosate, potassium salt, isopropylamine salt, and they have different inherent surfactant systems built in those. But we have seen the antagonism with all those formulations. So none of them seem to have resolved that antagonism with clethodim.
perfecto.
Great. There is another question that asks about mineral oils. Do you see any difference between methylated oils, that's what you showed us, and mineral oil? And if any, what would be those differences?
So we seen differences between the mineral oils and methylated soybean oil. Depends on the herbicide in question. I have seen beneficial results in going to a methylated seed oil over a mineral oil for the HPPD inhibiting herbicides, like a mesotrione, tembatrione. There's a benefit to those methylated seed oils. It seems like we get better activity, especially on grass species. But when we look at some of the diphenyl ether herbicides or PPO inhibiting herbicides, saflufenicil, lactofen, famecifin, we don't see as much of a difference in using mineral oil versus methylated seed oil. So it really depends on the herbicide active ingredient being used, whether we see differences between the two different oil-based adjuvants.
Muchas gracias.
Thank you. This question has to do with water hardness. Water conditioners to reduce hardness, in which herbicides do you think that they are the more important?
When it comes to water hardness, we've seen the greatest benefit of conditioning the water to reduce some of those hard water cations like iron and calcium. We see the benefits with glyphosate, glufosinate. We also see it with 2,4-D and dicamba, to list just a few off the top of my head. Those are probably the ones we see the greatest benefit. Probably the most influential would be indeed glyphosate and glufosinate, but 2,4-D as well in many cases, depends on the weed species.
Perfecto, gracias. Hay dos preguntas que apuntan a lo mismo. A ver,
There are two questions that are similar. Do you know of any cases when using a high range of adjuvants, oil-based ones, may be counteractive? Sorry, sorry, my fault. We will repeat it. Whether there are any cases when oil-based adjuvants used at high rates may be counteractive, may cause issues or problems.
Good question. So, if you have a herbicide that works very well with oil-based adjuvant, chances are you're not going to run in too many situations where you're going to have too much of that oil adjuvant to make sure the herbicide works. But if you're using that oil-based adjuvant in the herbicide solution because you're trying to mix an oil-based adjuvant for control of a resistant weed species, and you're still trying to use glyphosate or glufosinate or some or 2,4-D, there could be potentially some reduction in activity. For glyphosate, we can see that reduction in activity on some grass species because what happens when you apply a water-soluble herbicide like glyphosate with too much oil, the spray solution might try to go into the foliage of the plants through what we would call a oil-based route or a hydrophobic route, when glyphosate really wants to go through a hydrophilic or a water-loving route through that leaf surface. And so using too much oil might force glyphosate to move into plant a way in which does not optimize uptake. So that can be a concern if used with a water-soluble herbicide.
Thank you. Very clear. This question has to do with surfactants. What is the difference between ethoxylated alcohols and siliconated alcohol? What are the advantages and disadvantages of each of them?
So the difference between ethoxylated, which would be the very most common type of surfactant, absolutely cheaper in terms of cost, the ethoxylated surfactants, compared to one that has some silicon involved with it, that costs more. And the silicon-based surfactants tend to spread a whole lot more as well. So super spreading activity on the leaf surface. Now, with that being said, there's a lot of chemistry both in the ethoxylated group as well as in those that are silicon-based, because you can have some silicon-based surfactants that do indeed greatly enhance spreading on the surface, but there's also some silicon-based surfactants that are very good at leaf penetration. And there are some groups of ethoxylated surfactants that'd be in the same category. Some are very good at spreading and some are better at penetrating. It just depends on how much, if you will, hydrophobic nature is associated with that hydrophilic polar head group, the ethoxylated portion or the silicon portion. So silicon-based are going to spread more, and typically they're going to cost more. Is there a benefit to using those? Well, certainly silicon-based, where you want more spreading, might be a great benefit for fungicides. But in terms of herbicides, the benefit is somewhat reduced. Depends on if it also provides a lot of foliar penetration. That's when you might see a little bit more benefit of a silicon-based adjuvant system with a herbicide, as if it's a type of silicon-based adjuvant that also enhances the penetration into the leaf. But be very cautious, because there's some early research that was done with glyphosate several decades ago, 20, 30 years ago, that the silicon-based adjuvant system with glyphosate actually allowed the herbicide glyphosate to be stuck in the leaf cuticle. And so, yes, it moved off the leaf surface, but it couldn't move further into the plant to actually translocate it.
Bueno, perfecto.
Thank you very much, Brian. This is the end of the Q&A session. This has been an excellent lecture. We have all enjoyed it very much. Thank you very much again. There are some questions that haven't been answered, and there may be more questions coming in the future, because this has been a very interesting lecture. If you have questions, you may find the speakers section on the Aapresid platform. All these issues are very important. Besides the rates of herbicides used, usually farmers try to solve all issues increasing the rate. But this is a fascinating word, and sometimes it's very important to learn more about it, as we have learned from Bryan.